Okay, so I'm gonna spend some time talking about this, and we're just gonna stare at this for a little while because a lot has happened, obviously, and between this and the next step, a lot's gonna happen that I'm not gonna really go over because there's not much left to do actually. Um, Once I do a couple more wiring things, I'm going to then install this in the frame, and attach pretty much everything else, because it's almost ready for that point. So let me talk about what's happened. So last time the flight controller was on, I had just stuck it on there, and now you can see I have a. Okay, you can see that I like to use this 4 wide servo connector, because 3, well, obviously, 4 motors, etc. I have a 4 wide also on the other side for the OSD. I've got power, ground, RXTX, and that way when you want to disconnect it and update the OSD, you just pull that out. So I like to use these, and same with the motor. And if you ever need to update one motor at a time in BL Heli, all you need to do is grab this, stick one motor pin at a time into the little FVT, FVT, which stands for favorite, the people who made the Little B, or your Scilabs tool stick, whatever you want to call it. You stick one motor into the signal wire, and then any ground into the ground, and then give it power, and you can update the ESCs with BL Heli. So let's talk about this. As you can see, I've added all the ESCs and the battery. I'm going to strain relief this connection, the battery connection right here with the zip tie, because if you keep repeatedly pulling on this battery connector, one of these might get loose, and if the positive gets loose and then kind of floats around in here, who knows what's going to happen. You could have a fire. So here's my 5-volt and ground, and I've got a connection directly going to the flight controller for 5 volt. I've also got 5 volt split off going to the OSD, as I mentioned. And the only thing I have left to do is 2 wires for 12 volt, one going out the back, one going out the front, one for camera, one for VTX. And then I got these 3 wires to take care of. And again, these are buzzer, VBAT, and LED. Should be a piece of cake. I'm gonna grab ground and 5 volt from one of these for the LED. A buzzer. Ooh, I need 5 volt for a buzzer too. Shoot. Or maybe I'll grab 12 volt this time around. But anyway, I do need buzzer connection for positive somewhere. This will be ground, and then I'm just gonna cut this and stick it right onto one of these positive connections for VBAT. So that's pretty much that for these 3 wires. And then, like I said, the wires for VTX and camera are all that's left, and then this will go in the frame. Now it looks like a kind of a mess, but once it goes in the frame, all these wires are going to be tucked in between these 2 tabs, because if they go onto the tab, you'll cut it when you try to squeeze the frame together. So all the wires will be tucked in like this, and you can see I took the ground wires from the ESCs, twisted them 2 at a time, and then just soldered it right into one of the ground holes on the flight controller. Same with the other side. So my signal wires are technically grounded, and I'm going to cover this up. Some of this housing melted a little bit with the soldering iron, so I'm going to cover it up with a little bit of liquid tape. Same with any connections that I think might be exposed, like these. Once I'm done soldering the 12 volts, that is, I'm going to cover these up with liquid tape. So just a few more connections to solder. I may not go over that in the next build because I just shown it right here. And by that time, this will be ready to go in. And I'm itching to get this all put together, so there you go. So I've got everything hooked up, satellite. This is basically all the components besides the motors. And I'm just going to make sure that everything actually works before I button it all up. So I'm going to turn on or plug in this VTX. It's going to get really hot, so I'm only going to do this for a little bit just to make sure everything works. Got my ground station going off to the side. I had to bind the satellite on a separate receiver. The bind procedure, I don't know if it's broken or I don't know, it just didn't work. I did a Spectrum Sat bind and it just wasn't taking. So I've already, soldered this LED setup so that we can have some nice pretty lights going on. And we'll just verify that all of this works. Trick with this is just trying to keep all electronics separate so nothing's touching. We don't want anything to short or ground or what have you. Turn on the radio. Created a model. And beeper is gonna be a bit loud. It's nighttime, kids are asleep. Why the constant beeping? That's interesting. Why the constant beep? Let's unplug that. That's crazy. Okay, lights seem to work. Arm. LEDs are flashing. Increase with throttle. Yay. Okay, so the VTX is getting hot, so let's see. Okay. Ground station. Okay. Arm, disarm, voltage, and time. So the OSD works. Okay, looks like everything works. I'm gonna unplug the battery so we save that VTX. Except for that beeper. Okay, unplug the. Woo! It's not too. Oh yeah, it's pretty toasty. Okay, I do have a fan I could bring up here. Okay, well we need to test the other one, so let's test the other one. We'll move everything over a camera, VTX. Okay, this is basically a duplicate setup. Oh, same thing with the buzzer. And I'm looking at my ground station. Armed, yep. LEDs flashing. Alright, everything looks good. OSD information. Okay, well I verified everything works, so I'm going to start installing these in the frame. I took the frame apart. And by request, I'm going with the black standoffs on this one and black screws, all black. And I've got screws on one side, and we're going to assemble it like this. But just to prepare, I like to sometimes put Loctite in the threads themselves. It's easier than the screws, so I'm just going to squirt just a little bit. Okay, so we'll put that aside. It can dry a little bit, that's okay. And you can even dab the excess with a paper towel, and I might do that. Okay, so, whoa, what a mess. What happened? Well, it's all the wires. I mean, I did cover the bottom with liquid tape because there are some exposed electronics, and if you happen to have a wire that comes loose, it's going to rub all over, and that could be bad. So, I left a set of LED lights on this PDB. You know, I think you'd know if it was plugged in, but just to leave them there, I didn't cover that in electrical tape. Okay, so the trick with this is going to be installing this in here. And obviously what we need to do is make sure that none of these wires get pinched. So I'm going to start with one side. This is the rear. I want to make sure the wiring goes below the standoffs and above this standoff in the front here. So push the ESCs through. Okay, so as you can see, all the wiring should go above the front standoff and below the rear motor standoff. And then this battery lead is going to go below the arm itself. So now when we put the other side, we need to make sure that the wires need to go where they need to go. So this one's the tricky part. The rear arm needs to slot right here, but the battery lead needs to go underneath. And then it's going to sit between the arm and this rear standoff. So double check to make sure no wires are pinched. There we go. Snap. It snapped. Okay, it's in. Alright, so I'm holding it, double checking. Okay, it looks good. So what I'm going to do is I'm going to put one of these 6mm screws in two of these standoffs just to hold it there. Okay. Managed to get both sides in. This is the tricky spot right here on the second plate that you install, because these wires will start to get pinched, and you can see it's starting to crawl up into the space between the standoff and the screw. And that's okay until you tighten it. When you tighten it, just make sure that that wire is not there, you know, or you could try to move it towards the center. There we go. For now, we'll keep it right there. So that way it's tucked out of the way of the screw, so the screw won't pinch it. So we'll leave it like that for now. The frame is somewhat loose. I'm going to loosen this one a little bit because we have one more plate to install. So I'm going to loosen it enough to be able to separate it, but not enough for it to fall apart, because we have to install the battery plate. And then once we install this, we can actually tighten it up enough where it won't move. So I just slide this in while the frame is loose. It's hard to see under the camera, so I'm going to move it over. Okay, make sure both plates are in. I'm holding it with my hands. Double check your wires. Nothing being pinched at the tabs. Inside the frame or at the standoff. So I'm going to go ahead and slowly tighten this. And if you feel any resistance, that probably means you're pinching the wire. So I'm going to take a look. I don't feel resistance, but I'm just going to double check. Tab is in. Tab is in. Wires are clear. This is really just, this takes patience, this part especially, so just be patient. It's almost together. So alright, I'm going to tighten a little bit more, and same with the one on the top. Okay, now at this point the frame at least won't go anywhere. Your parts won't fall out. So this will be pointing to the rear. This is for the VTX, which will be right there. LED lights. Okay, let's get the wires out of the way. We can leave the camera cable hanging, but let's test fit the rear arm. So with the rear arm, basically you want to grab this XT60 or your battery plug, because that needs to go below the arm. You don't want to do it like this, right? So you want to do it like this, because up on the top of this the VTX is going to sit. So we're going to grab this and just slide it in and test it out. I did remove, in the previously you saw I had the standoffs there. I did remove it just so I could slide this in. Okay, check the wires. The ESC wires are above, battery wires below, and this should just slide in snugly. The wires will be kind of, the ESC wires are pretty durable though, so they'll be kind of in the way, but there we go. You just have to, they're not being pinched, but they are being squeezed just a little bit. We want to make sure there's plenty of room here for the VTX. Okay, so relax that a little bit. Put on the side plates. And let's loosely put the standoffs and screws in there. These are the 8mm. You may have to push forward as you, there we go. just flush with the plate so that we can put the standoff in. Pressure will hold it. So I am going to use tweezers just to get this one standoff in there. And if you wanted to have the standoff in there already, you can before you assemble the other plate, but that means the arm has to be in there as well. Back off just a little bit. Okay, don't tighten it all the way because the pressure will cause it to, so you want it to, I'm going to be able to get it from the other side. Loctite, right? Yep. You may have to give the arm just a little squeeze. There we go. And again, just double check wires, make sure nothing got into the standoff and is being pinched. Looks good. A little bit more snug, but again, not completely tight because we're going to do that at the end. We just need it to stay there. Same for the rear. Now, I like to put the battery wire underneath this standoff, so it's not hanging loose because the battery needs to go there. And it will squeeze it, but that's what I want. Okay, just now. And I actually put this extra piece of heat shrink because when I put a zip tie there, you don't have to have a zip tie honestly, because the strain relief is there, but I liked it just as extra strain relief. So I think it works best that way. Just snug. Okay. This is triple checking, no pinched wires. That's very, very important, that part. No, it looks good. So that's basically it. Oh yeah, one more plate in the front. I've assembled everything, quadruple checking. Oops. To make sure I didn't pinch any wires. So it's pretty much assembled. I got the battery plate in there. And there's going to be some foam and some Velcro. I folded back the heat shrink, and it's not difficult. I mean, you just gotta fudge with it. You sit there and you do this. You fold it back. Yeah. In fact, I'll get this one ready for the next frame since I'm building two of these at the same time. So just go like this. And just like that, it's folded back. And then that way, because otherwise it'll be covering up the motor pads and you won't be able to solder, or you're going to melt the heat shrink. So this way it gives them room. And we're pretty much ready for motors. Just make sure all your wires are in the right place. One important thing, before you do the motors, if you want the landing gear, you need to at least have this part of it on, because the motor wires will be covering up these holes, and it might be very hard to get this on afterwards. So, and do not Loctite this. I repeat, do not Loctite this, because this rubber is very pliable, and if you Loctite it, you won't be able to get it off without destroying it. And by destroying it, you'll probably scratch up the carbon a good deal, which normally I don't care about, but it's also just a big hassle. So really, do not put Loctite on this screw. As you can see, the end of this already has teeth, so this should hold pretty well. And don't even crank it down when you tighten it. Just, maybe this one, 2-finger torque wrench. 2 fingers. Stop. 2 fingers. Stop. That's all it needs. It won't come off. It's rubber, so. Okay, motor time. So, this frame is the aluminum screw version. This is the one I'm building for myself. I've put the rubber isolation thing for the landing gear, And now I'm going to mount the motors, and then I'll take it downstairs and cut them and solder them. Like I said, I'm going to cross 2 wires for 2 of the diagonal motors, and then for 2 of them I'll just have them straight. And that should take care of having them all the same in BL Heli. With these motors, I always check, and these happen to have a 1.5. Some of these have like a 0.9 millimeter grub screw, but this one's got a 1.5. So what I usually do is I find the grub screw just to see if it's tight. A lot of these are loose, so I check. And I do the 3-finger torque wrench test. So I'll take my 3 fingers and just gently see if it'll come loose. This one's pretty tight. If it's not going to come loose, I'll just leave it alone. That means it's pretty good, or they've already put Loctite on it. If it's loose, it'll just come loose pretty much with 2 fingers even. So 3 fingers, it'll definitely just come loose. And in that case, I would take it out, put some Loctite on it, put it back in, make it nice and snug. If you do happen to break it loose by accident, and it was pretty tight to begin with, I would reapply a little bit of Loctite and then put it back. That's just me personally. And I also like to oil motor bearings before I put them in for the first time. I have a needle oiler downstairs, and I'll oil it through here. There's bearings on the bell side, so I'll stick the needle oiler right in here. You can see the bearings, and then I'll put just a drop on this side, and before I mount it, or even after you mount it, because you can get to it from the bottom of the arm. So yep, we're gonna mount these, measure, and then cut, and then solder. Okie doke. Oh, you know what? A real quick tip. So Hobby King sells these micro extensions, or like micro JST extensions, and you can see I'm using it here. So it's an extension, which means it's got a male side and a female side. Well, if you cut it in the middle, or even more towards the one end or whatever, you now have a micro connector. So you solder one end of what you cut to like the LED portion of your flight controller, and the other end to your LED, and then use the connector. And instead of a big honking servo connector, you now have a micro connector. And you can use that for any 3-wire connector that you need, that you want to be able to disconnect and connect. Instead of fiddling with these 1 millimeter whatever pins that you have to crimp, you have to buy a special tool to crimp. That takes much longer than just splicing a pre-made wire for you, and the cost is very minimal. For one thing though, in my builds with this frame, I much prefer the motors to spin in the opposite direction. So normally the front motors, and I mentioned this in the very first video, the front motors spin normally inward at the front. I have them spinning outward, and I explained that about the pockets of air and everything. You know what it also does? It kind of helps keep the lenses clean, as Jared kind of tried it. My lens is kind of protected by the side plates, but still, it spits the dirt out kind of sideways at the front. So that's what I did. I'm about to cover these ESCs with this HVAC tape. This is like silicone tape. You know, it doesn't stick to anything. Right in the middle of the ESC. Pull. Pretty cool stuff. I have some in red too, but I think on this build it'll just be black and blue. Alright, I'm going to do all 4 of these. Hook up the receiver, the VTX, camera. That's all I have to do. Just place them in there. VTX, receiver, everything installed. I have to keep this buzzer from moving around a little bit. That's okay. Oh, I use these little screws for securing the camera. And what I like about it is it's a standard size. It's not metric, but you can take a 2mm metric and fit in there and hold it. So I take the screw. It's kind of long. This is the length, and this is what it looks like after I cut it down. So I cut it down. Let's see, it needs to go into the camera about 3 to 4 millimeters, and then the frame is 1.5, so roughly 5 millimeters. And I start it with this one, so the threads get started, and then I just use this. You'll hear some plastic breaking. It'll like crunch, but it holds the camera in really well, and this is much easier to adjust later on than those really soft Phillips screws that come with these cameras. So a layer of this, again, very strong and very sticky. A layer of this is like foam from Hobby King. It's like 3 to 4 millimeters thick. This will be very strong. I'm gonna line it right up with, let's say, little gooseneck, and then it's got the hole in the center, so you could look through it with a magnifying glass if you wanted to. I'm gonna use these cheapo straps for the GoPro/Yi, just because I've got enough of them. Might as well go through them. So that strap's gonna go there. That's gonna go in here. Okay, I'm gonna get these started. I already put Loctite on these earlier in the day. They should dry by now, but that's good enough. So the only thing I have left to do is cover the antenna wires. My camera's already placed in there. I'm ready to go, except maybe get a better VTX antenna. Okay, so now I can tighten these down. Alright, uncover the beeper. That's pretty much it. Let's see, let's try the radio. DX9. Put the battery in. Much better. And I just strapped that the balance lead in. Just like that. So there you go. It'll squat on these short front standoffs. And it's great for racing because it just takes off like that. And you start going forward already. You don't have to go up and then forward, it just goes. It's kind of nice. Okay, here we go. I like to twist the battery lead before I plug it in. Multi-shot for you. Ooh, it's nice and loud. Beeper works. Armed. Let's see, air mode. Oh, it's just barely.
Normal mode. 3D
Air mode wants to. I may have to raise mid throttle a little bit. That's interesting. Oh, it beeps at 0 throttle. Okay.
normal mode. 3D race.
Verify motor directions. If I dip left, the left motor should speed up. Yep. Yep. These Emax motors are some of the smoothest stock motors. I used to spend a lot of time balancing motor bells, but these aren't really necessary.
Normal mode.
I know the build video has been kind of long, so I'm going to summarize if I can real quick. Test fit the frame. Don't forget the arms might be different thickness, so if they are, file down whatever you need to for these spacers, and then keep the front ones and rear ones separate if you have different thickness arms. If the side plates don't quite touch the tabs on the arms, you want like just a little bit of, you want to see a little bit of daylight between the side plate and the center of the arm that it's going to compress. Because if it touches completely, then, you know, I don't know if you have the room for it's going to loosen up after a few crashes. So you want to see just like a hair of daylight. If they don't get that close, if they're like a millimeter apart, don't grind the arms too much, because you want to, if you have to grind the arms so that the side plate fits on, that's fine. But once this side plate fits on the arm, this side plate, once it fits on the arm, if you keep grinding the arm, then this will be loose, and you can't fix that. You can grind the hole in this side plate, the main side plate, the arm slot, and that way this one will still do its job. If this one's still a little loose, these holes will line it up, the 3mm screw holes. Okay, very important not to grind too much off of this one. Okay, and even this one, just a little at a time, always a little at a time. See this gap here? I don't know if you can see a very slight gap. That's okay, because that means it's being squeezed. The carbon's bending a little bit. In fact, if you look at it from the rear, it's almost a trapezoidal shape. It's wide at the bottom and starts to get narrow at the top. That's okay. And even from here, you may see it bow out in the center and then get skinnier towards the front and back because it's squeezing on these side plates. That's okay too. In fact, you almost want that, because you want everything to be under some bit of tension. Okay, and then measure the ESCs. So after all the filing, the fitting, making sure everything's tight, measure the power leads and the signal wires for the ESCs. If you go back through the video, I gave dimensions, and you can use those as starting points. I don't have them. I should have written them down, but I don't have them. But measure the power leads and ESCs. Don't forget that they're swapped on that power board, the PDB. So on one side it's positive negative, the other side it's negative positive. And make sure you measure it, remembering that PDB will be upside down in the frame. Okay. If you want to fit that OSD on the front, the back ones are going to be much shorter than the front ones, because the PDB will be pushed to the back. Okay, the signal wires for the flight controller, I'm not going to go over. There's too much detail. But don't forget to put some kind of bootloader jumper so that you can jump the bootloader. See, if I had to do it now, and if I hadn't done that, I'd have to take the flight controller out and get to the bottom. So add some kind of wire, and also take the 3.3 volt off of that for the Spectrum satellite. If you're using Spectrum satellite, you can of course use a Taranis PPM, and I've used a Spectrum PPM in here. It'll fit. Taranis PPM, I believe it's small as well. It should fit. What else did I go over? So solder, I covered the bottom in liquid tape. Strain relief on the battery plug, and I'm going to put one more here. I haven't yet, but there will be one there. Let's see. I tried buzzer off of 16 volt and 12 volt. It just constantly buzzes, so it has to remain 5 volts. What else? When soldering up the motors to the ESCs, I crossed the wires on front left and right rear. That's motor 1 and 4 in Betaflight. And then I left my motor direction in BLE normal. Now what you end up with that combination is reverse spinning motors, which on this quad, this design, I believe is beneficial. The only problem is if you have another quad that doesn't, just remember which way the props go on here. It probably won't flip over, but it'll just stuck on the ground, so which may actually cause it to flip over, because Betaflight doesn't like it when it's trying to do stuff, and it can't. So I like to run 5x4, 5x3 with these motors. What else? I believe that's the main stuff. Loctite on the screws. I'm not gonna go over the pinouts for LEDs and VBAT and all that stuff. That should pretty much be it. So yeah, I mean, on my channel you can see plenty of videos of my first one and my second one, the prototype, and then the non-prototype flying, and I love the way this thing flies. You know, it's not the lightest. There's lighter ones. I feel like the QAV, for instance, that QAV 210 is really light. That thing's fantastically light. However, I've seen them break pretty somewhat. I don't know. I wouldn't call it fragile, but and of course the big advantage of this thing is you can do this and not have to mess with the CG. To me, that's huge. I mean, I like to record sometimes, most of the time. Sometimes I don't. So, there you go. Yeah, it does stick off to the side. You can't do anything about that because these cameras always have the lens on one side, but it still flies great. Alright, next video will be tuning.